What's up? What's up? It's your man Jimmy Chan. All right, so today we're talking about transformations. So these are called parent or key functions. So a constant function would be a horizontal line where y or f of x is equal to some constant number. It even tells you what the domain and the range is, right? This is where, if you guys remember, the range would be a single value while the domain would be negative infinity to positive infinity, right? Y is equal to x squared, right? It's actually quadratic. Now, before I continue on, one of the things I want to talk about is parentheses, right? So when we do this, we have to remember that there is a parentheses around that x, and anytime I find f of 2, I usually like to, when I replace the x with a 2, I like to put the parentheses around it. So please remember that, okay? So it doesn't matter which function it is, even though if it's as simple as y is equal to x, I want to put parentheses around that x. All right, and then we have also the square root function, which is y is equal to the square root of x. If this would stop snapping in the spot, it'd be great, but it keeps on snapping in the spot. But anyways, it's okay. So if you noticed that with the square root of it, when x is 0, square root of 0 is 0, 1, square root of 1 is 1, 4, square root of 4 is 2. Okay, and notice the domain and range. Now, one of the things that you guys have to understand here is that notice how the graph, is only in quadrant 1. It has already determined that this is only going to be taking the positive side of the y values, right? The x values, I cannot take a square root of negative. That's why you have nothing on this side. But usually I can get this end because it would usually be plus or minus. But this is clearly saying we only want everything on the positive side, okay? All right, so with that being said, let's go ahead and drag these parentheses to the next set of parent and key functions. So this is the cube function. So y is equal to x to the third. This is the reciprocal, so it would be 1 over x. So the parentheses will be around the x. That's essentially the whole denominator. All right. And then we have the cube root. Now, we can take the cube root of a negative number. That's the reason why you can see that we have negative x values with some kind of y values to it. All right. And then last but not least, this is the absolute value. And with the absolute value, what we have here is that absolute value means the distance from 0. So when x is 1, the absolute value of 1 is also 1. And the absolute value of negative 1 is also 1. The absolute value of 2, negative 2, is 2, and the absolute value of 2 is also 2. So it's the distance from 0. So, for example, if you're saying, hey, Mom, I'm going to go to my friend's house, and when she asks you, where is it? You'll be like, hey, it's just 2 houses down. You don't specify negative 2 houses down. That means to the left 2 houses, or positive 2 houses down, and call that to the right. You just say it's 2 houses down, meaning it's the distance from your house, okay? So that's what absolute value really is, all right? So, and then notice the graph really gives you a V shape here, all right? So let's talk a little bit more about transformation. So these parent functions are important because that's where we're gonna start with before we do our actual transformations with these actual graphs, right? So we're actually transforming these graphs to something that looks similar, but not the same anymore, all right? Just like if we went through a transformation, we look the same, but not quite the same anymore, all right? So let's start off with this. So typically you're gonna be told that g of x is equal to this right here. So a times bx plus h plus k. right? So everything inside the parentheses is always gonna always affect the x value. So we notice that this is highlighted in yellow as well, all right? Is attached to the x, is inside the parentheses. Everything in here affects the x value, while everything outside that parentheses is gonna affect the y value, okay? So let's keep on going. So when I say that, well, yeah, let's go back to the parent function. So as you guys can see, where I have the parentheses right now, everything inside affects the x because it's around the x. Everything that's outside of these parentheses, so out here or back here, those affect the y value, right? Same thing in here, affects the x, out here affects the y. In here affects the x, out here affects the y, okay? All right, so let's continue on. So everything inside the parentheses, guys, affects the x value. We already said that. However, okay? However, actually, did I miss one? I did not. Now, everything inside the parentheses not just affects the x value, but it is backwards. Even the order of operation, meaning if it's telling me to add, I subtract. If it's telling me multiply, I divide. If it's telling me to divide, I multiply. If it's telling me to subtract, I add. Everything outside, which affects the y value, as we said, well, those operations are straightforward, including the order of operations. So even the order of operations backwards, okay? So let's continue on. So let's take a look. It says everything inside affects the x value. So horizontal shift, if it says add 5, I shift left. Add h, I shift left. That means I subtract h from the x value. If it says minus h, I shift right. That means add h to the x value, right? Everything's backwards. If it says to multiply by b, then I divide the x value by b. If it tells me to divide b, then I multiply the x value by b, right? And then if it's a negative b, which would be multiplying, which now becomes divide by negative. Well, if I divide b by negative, it's going to be a negative b anyways. That's going to reflect the x value. It's going to reflect over the y-axis, meaning the x value either going to go positive to negative or negative to positive. Okay, so let's take a look on example here. So here I give you a parent function, which it says f of x is equal to x squared. So it looks something like this. So here's the thing, guys. We can always get these points for the parent function, right? It says y is equal to x squared. So I can come up with some x values like 0. 0 squared is 0. So I got 0, 0. If I put 1 in here for x, 1 squared is 1. If I put 2 in here for x, 2 squared is 4. So at 2, it'd be 4, and so on and so forth. So I can always figure out what that parent function looks like by just plugging in some x values, right? Now, what if the function that they want us to look at is this function here, right? It says that g of x is x minus 2 squared. So notice that this is in the parentheses. It says minus 2. So what does the minus 2 mean? Since inside the parentheses everything's backwards, minus 2 means to add 2. So meaning shift right 2. So if I had this as my graph, bring that right over here, then what happens to this? It just, let me duplicate this and let's change it to red and solid. So what will happen is that it will shift right 2 units. Okay, so let me write that down. Shift right 2 units. Okay, because it affects the x. So the x only goes left and right. Okay, so notice what happens there. Okay. All right, what if we had this one here? G of x is equal to 2x squared Okay, let's take a look at that. How would it affect that right there? Okay, so how that would affect that is that if you notice it's inside the parentheses, right? The square term we really don't have to worry about because the square term is already here. So the square term is kind of like, I recognize as the x squared, but I don't need to really do anything with it. So since this says to multiply by 2, I actually divide by 2. And what am I dividing by 2? The x value. So I'm taking the x value. So if you look at this x value here, what is the x value? -2, right? So if it's -2, if I divide by 2, it becomes -1. If I took this x value, which is 2, and if I divide by 2, guess where it goes? To 1. And this x value here is 0. If I divide 0 by 0, it's going to be still 0. All right? So what will happen here? Let me change this to blue and solid. All right? Is that this is going to do something like this. Okay? Now notice what just happened here, guys. Right? My x changed. Right? My x became half of it. Okay? So notice my height didn't change. My y did not change whatsoever. It's just my width changed. Okay? And it went to half, so it looks narrower. All right? So what if we had this last one here? So what this is telling me is to multiply x by -1, and it's inside the parentheses, so it's that clearly affecting the x. So it's multiplying the x by -1, which tells me to divide x by -1. Well, so if I took all the x values and divide by -1, it's just going to flip the sign. So if I took this x value here, which is a 2, and divide by -1, it's going to become a -2. And if I took this x value, which is -2, and divide by negative, it's going to become a +2. So in other words, if I was to call this side A and this point B here, right, what will happen is this. So make it purple and make it solid. So now this is just going to literally flip over like so. Ooh, undo. And it's going to become the same exact thing, except now A is going to be this side and B is going to be this side. Okay, so it actually reflected over the y-axis. So this reflect over y-axis. I forgot to do this. I guess I'll call this a horizontal shrink by 1/2. Okay, so that is how those would affect the so-called x value. All right, so because those are all, notice that is inside the parentheses. Okay, so what happens when it's outside the parentheses? Let's take a look. So everything outside the parentheses affect the y value and is straightforward. So the A is a vertical stretch or compression. So if it says to multiply by A, we multiply the y value by A. If it tells me to divide by A, I would divide the y value by A. And if it says to negate A, I would negate the y value. Okay. Now the K is a vertical shift. So if it says add K, I would shift up, add K to the y value. If it says minus K, then I will shift down, subtract K from the y value. Okay. So, I don't know if you guys realize this, but I put this in basically in order of operations. Okay, so when I look at this whole thing, order of operation tells me to do parentheses first. So I'm in here in the parentheses. That's why I'm doing the inside of the parentheses first. But inside the parentheses, I have to restart the order of operations. But the problem with inside is backwards. So it's no longer PEMDAS, it's SADMAP. Okay, so I got to add, subtract before I multiply, divide, before I can do my exponents, and before I can do my parentheses when I am in here. All right, so that's the reason why I have the horizontal shift first, because I have to add or subtract before I can multiply or divide. Okay, then once that is done, I come out of the parentheses, my order of operations back to normal, right? So parentheses, exponents, there's none to take care of. Then I multiply. That's why I have this. Then I add or subtract. Okay, so I went inside, which was backwards, came out, went back to normal. Thank goodness, right? So let's take a look at these examples right here as well. All right, so let's do the same thing. So this is outside the parentheses. All right, and this is telling me to take the y value, because notice that here's the parentheses here, and this is outside of that x squared. Okay, so if that's the case, I still have my parent function here. This tells me to shift down 2. All right, so if I was to take this, it's going to change it to red and solid. It's going to take this and shift it down 2 units. And that's what it would do. Over here, in the bleu, what's going to happen here? Okay, so this is multiplying the y value by 2. Now be careful. It's multiplying the y value by 2. All right. So if it's multiplying the y value by 2, what is it doing? So let's see here. So we know that this is a y value of 4, right? If I double that, it's going to be 8. So let me go ahead and put a blue dot here and a blue dot here, just so that I can have a reference. Let's take that, duplicate it, change that to blue and solid. Okay, so there it is. It's going to take my y value and it's going to bring it all the way up to here. But if I took my y value of 0 multiplied by 2, it's still going to be 0. So we notice the difference between the black dotted line and the blue is that the height doubled, right? This is called a vertical stretch. Okay, happens to be double the amount, right? Because it's 2 times. So it's double the amount. So notice how my x, however, never changed. Only my y value changed because the 2 is affecting the y and not the x. All right, how about this one over here? What would this look like? So let's change this to purple. I did not want to duplicate it. I want to change it to purple. All right, and then I gotta paste this here. All right, so what does this actually want me to do? So this is telling me to take the y value and multiply by -1. So if I have my y value here, which is 4, multiplied by -1 is now going to be a -4. Same thing here. If this is a +4, is now going to become a -4, and 0 is going to stay 0. So that reflection, purple, solid, and that is going to now look something like this. Oh boy. 2, 4. Now it's going to look something like that. All right. So what is that called? Let me go ahead and move this whole thing here down a little bit so I have a place to write. So here I reflect over the x-axis. Okay, so that is what we did. So those are several examples when it's affecting something just singularly, right? The next question is, okay, what if there was more involved, right? So let's take a look at some different examples here. So another example that you might get is something like this, right? Where it's going to say, okay, so here's the order I want you to do it in. Give me that equation, right? It's a shift up 5 units. The problem it doesn't tell you is that the parent function or key function is f of x is equal to, let's say, the square root of x. Okay? So if I am shifting up 5 units, what that's telling me to do is I have to add 5. So let's put it this way. Add 5 to y. Okay? All right. So my g of x is now going to be the square root of x. Actually, let me do it this way. Undo. And I'm going to add 5 to it. Okay? Then it tells me to reflect about the x-axis. So if I reflect about the x-axis, what happens? So if I flip over the x-axis, doesn't my y go from positive to negative or from negative to positive? It does. So what it's saying is, okay, so what I'm doing now, so I should probably put this as 1. So this is going to be 2. So now what I'm doing is I'm taking what I just found in 1, and I have to go ahead and negate it. Okay, because what I did was I flipped whatever value I had in the after I get the first thing done, I'm gonna go ahead and flip over the x-axis, which means it's outside of that square root, so it affects the y value. All right, so 3 says to reflect about the y-axis. Okay, so here is 3. I can put it right here. So that means I gotta take whatever's here and I'm gonna affect it with 3. Well, 3 says to reflect about the y-axis. So if I reflect over the y-axis, what changes? Either the x goes from positive to negative or negative to positive. So the x, so that means it's inside that radical. So that means it's gonna be affecting in here. And there is where it affects it. So that is what I have, but my final answer from that, if I distribute that negative through, right, I'm going to have negative square root of negative x minus 5 is going to be my so-called g of x. So notice something. whatever we call the parent function, typically is called f of x. Our transformed is typically something going to be a little bit different, not going to be called f of x again. You can call it g of x, h of x, L of x, whatever you guys want to do, but it's never going to be f of x again, okay? So please make sure that you kind of keep that in mind as you guys are going. So I should probably, however, I did it for the first one, but I forgot to do it for the second and third. So reflecting about the x-axis means that I negate the y value. And then reflecting over the y-axis, I negate the x value. All right, so there we go. I hope that makes sense. And then let's hit one more example. This is what's going to happen most often, is where they give you an equation and tell you to graph this. Okay, so they won't tell you what the parent function is, but see these signs right here? This sign and this sign right here is a dead giveaway. Same thing with the x squared that we had up here, right? So it's a dead giveaway whenever I see square terms. That's probably my parent function, right? Where here, if I see a radical or a square root in my transformed, my parent function is probably the square root, all right? And here, because I see these two signs, that means my parent function must be the absolute value of x. Okay, so with that being said, let's first find some points for this. I would typically want to let's make 4 points, okay? So x value, so this side is going to be the absolute value of x. Okay, so let's do a couple points. Let's say -2, -1, 0, and 1, okay? So let's go ahead and do the absolute value of 2, which is going to be 2. Absolute value of -1 is 1. Absolute value of 0 is 0. Absolute value of 1 is going to be 1 as well. All right. So let's go ahead and write those points down. So I got -2, 2, -1, 1, and 0, 0, and 1, 1. So this I can actually physically do right in front of you, all right? And I'm going to use points to kind of make the transformation happen, all right? So let's take a look at this transformation here. So if I was to look at this equation, what is the first thing I would do? I would deal with parentheses first, because that's what the order of operations says, right? Parentheses, then exponents, multiplication, division, addition, subtraction. So I would deal with parentheses first, which is exactly what this is, all right? So I would deal with this first. So essentially there is a parentheses right there, all right? So inside the parentheses, however, everything's backwards, including the order of operations and the operations itself. So if I had to start the order operations backwards, what is this actually doing? So here might be a good idea for you guys, because the first thing you're going to say is, well, that means we have to subtract x first. Well, yes and no, because subtracting x in this case is actually multiplying x by -1. So you might want to rewrite this g of x as -2 times the absolute value of -x plus 7. So you guys might want to do that just so you guys can see better of what's actually happening here inside this parentheses, right? So the first thing here that I can see happening is that, so inside the parentheses, order operations backwards. So we got to do addition, subtraction first, then multiplication, division, then exponents, then parentheses. So I actually have to deal with this first. Wow. Okay, so I got to deal with that. What does that tell me to do? This tells me that I have to add. So let me do this. So I have to add. Oh, sorry, backwards. So take the x value and subtract 7. Okay, so I have to look at the x values and subtract 7. Because again, everything inside the parentheses is backwards. So since it's inside the parentheses, it also affects the x value. That's why these are all under the x value. It does not affect the y value at all. So that means when I write these points, guys, the y value has nothing to do with it. So the y value stays exactly as is. It's the x value that got changed. So what do I have here? I got -9, -8, -7, and -6, comma, right? All right. So now what's next after that? What's the second thing that that needs to happen? Let's go green. Okay. So that means the next thing I got to do is this right here. All right. Which I believe is telling me to divide the x by -1. So the green is telling me to take the x and divide by -1. Okay, so I'm going to take the x and divide by -1. So again, notice that I did not do anything with the y value still. So y value is still 1, 0, 1, and 2 here. So there's now +9, 8, 7, and 6. Okay. Now everything inside the parentheses is now done. I come out of the parentheses. The last thing is a -2. So let's call that purple. And that affects what? That affects the y value. All right. So what am I supposed to do? I'm supposed to take the y and multiply it by -2. So -2 times the y value. So multiply this by, you can do it this way if you want, -2, multiply this by -2, multiply this by -2, and multiply this by -2. So what do I have as my final point? Maybe what I should do is, should I use something a little bit, well, then the highlighter is going to be darker. You know what? I'm going to assume that these were all brown. How's that? Just so you guys can see, because the yellow I'm sure is very hard to see. So let's just call it brown for now. So my final point here is going to be, so notice how the x values didn't change at all, right? So let's see here. So the x value stays at 9, 8, 7, and 6, while the y value now became -4, -2, 0, and -2. All right. So let's go ahead and graph this and see what that looks like. So here we go. Just in case, right? All right, so here's my so-called x, here's my y, and my parent function was this right here, right? Was the -2, 2, -1, and that. right? So I had something like this. And something like this. Okay, so that's why what I'm supposed to have as my parent function. So this right here, I'm going to go ahead and make it dotted. Same thing here, make it dotted. So that's my parent function. This is f of x. Okay, so let's take a look at what happened here. So the first thing was a blue, right? If I plot the blue points here, it would have been -9, 2. And then -8, 1, and then -7, 0. So in other words, what would have happened was this right here would now be the blue, and this right here with the blue. So what happened with that +7? It affects the x value, so it's shifted left 7, even though this says +7, it's opposite, so it's shifted left 7. Okay? That's not the final answer, that's just an intermediate answer. Now, the next thing we did was the green, right? We did the green, and what we did was negate the x, or divide by -1. So here's my new answer, and we said that that is going to be a, so what happens when I negate the x? So now it's going to be a 9, 2, 2, 4, 6, 8, 9, 2, and then 8, 1, and then 7, 0. So in other words, now this right here is over here, this over here is over here, like so. Let's change that to green and change that to green, right? So what happened from the blue to the green? The x negated, so anything that was a positive x, negative x value became positive x values, okay? So again, that's still not the answer, that's just an intermediate answer. The final answer is this piece right here, right? So after we got this done, we came out of the parentheses, and there was only one thing that's attached outside the parentheses, which is the -2, which affects the y value. So it tells me to multiply the y value by -2. Okay, so the negative is going to actually flip this, and the 2 is going to tell it to grow taller. All right, so when you do this, when we look at this, here's what happens, right? So it's now 9, -4. So it's 9, -4 is here, and then 8 is -2, and 7 is 0. So what actually happened was this is happening. Isn't that right? Let's see. Yep. And then this is happening. So this, ladies and gentlemen, is my final answer from that parent function. So if you notice, doesn't it look narrower? Meaning it got stretched taller, okay? Because this is affecting the y value, so it means to double its height. The negative is actually telling it to flip over, so whatever is positive y became negative y, and then the 2 tell it to grow taller. So that's what the final answer would be from the parent function to this. So if you look at this, this tells me to shift left 7 units, flip it over the y-axis, then flip it over the x-axis, and go twice as tall. All right. I hope that helps. If there's any questions, please let me know. See ya. Bye.